Hi, welcome back. So in this video I'm going to look at putting a fourth axis on a gerbil, GRBL based CNC mill using UGS as the driving software. There are some limitations to doing that, most notably that Fusion, the free version of Fusion, doesn't support more than 3 axes. So in order to use your fourth axis you have to manually enter the G-codes to rotate the table. I'm essentially using it so far as an indexer, a CNC indexer, so I can increment at 90 degrees. I have had a couple of attempts at making the fingers for my lathe steady. It's quite a learning curve. Neither of them are perfect. I think the second attempt might be good enough to use, but I've got a feeling I might have a third go, just because I'm trying to get my head around the process and the limitations of the machine. Now what you're going to see is essentially how to set the axis of rotation 0 on the mill when you've got your part in the fourth axis, and I will test that by drilling a hole on one side, rotating the part around 180 degrees, and then making sure that the hole is perfectly aligned. When you get a fourth axis attached to your machine, the first thing you'll definitely need is a control board that supports 4 axes. Now I bought a fairly cheap one, I think it was about £30 off eBay, but it does 4 axes and doesn't do anything else special, but it seems to work. What happens is when you open UGS, if a fourth axis is detected, it will show these A plus and A minus buttons and step size ABC, so basically it can support up to 6 axes. So I've got my step size set to 90, so I can do 90 degree increments of rotation, and if I just do that, it rotates quite nicely. And I have tested this a fair bit and it is surprisingly repeatable. So if you've got an incredibly good memory, or you just happen to have watched my last video before this one, I had mounted the rotary table along the centre slot. Seemed like a sensible place to put it. But as it turns out, the travel of this machine is actually centred on this back slot, which is less convenient, but that's what we've got. So I've had to move it back, and because of that I've only got 3 clamps on it now instead of 4, because I can't get the 4th one over this side. So it's worth checking where the best place to position your rotary table is, because if it's anything like this, then it's not dead in the centre of the table. So for probing the material and working out where it is and everything, I've got one of these little 3D probes. They're about £65, and so far it's actually really good. So what I wanted to do with this rotary table, because I've never used one before, and I wasn't really quite sure how to indicate everything in to work out where the axis of rotation is and everything, I wanted to do a little test. One thing I did do was got out my torque wrench, because this thing says 40 Newton meters. So I've set my torque wrench to 40 Newton meters, and it's actually a surprising amount, especially when there we go, the little jaws on this vise clamp down nicely, and here we go. Now that's going to take a little while because I'm a bit far away. Hopefully it's less than 10mm though, and there we go. What we want to know is where the centre of rotation is. So actually I want to zero the Y where it is at the moment, which is the furthest point from the centre, and then what I'm going to do is go up a fair way, just so I'm out of the way and I don't bend my tip. And if we go around 180 degrees, probe again. So that value is now 57.475. The centre is going to be half of that, so we can do, I think we can do divided by 2. So we've clicked the Y value, it brings up this little window, and you can do that, and it gives you half the value. So that means if I come up in Z first, and then now whilst that is not the middle of the material, it's the centre of rotation. There we go. Now let's go up, and we'll put our drill in, and we will do our little test to make sure that we're in the right place. So I've made a little bracket to keep it on the wall because it is kind of delicate and keeps it out of the way. I've put files for that on Printables. You're free to download them if you want. So I'm just going to drill this manually with the buttons on here, but I've set my feed to 150 millimeters a minute, step size of 1 millimeter. So I'm going to go down 2 millimeters and then back off 1 just to break the chips. And to start the spindle, we do S3000 M3. Right, M5 to stop the spindle, and then if we just go up a little bit more, oh, we want to go a bit quicker than that, really, don't we? That's better. Now if we go 90, another 90, swarf off, and then we want to go to 15. Now if we go down, the drill just drops in perfectly, which means it's aligned rotationally, front to back. It's not excessively leaning, and squareness to the table is pretty good. Obviously it's not a very large distance off the centre because it's not a very big block, but I'm not going to be doing massive pieces with this anyway, so to me that is more than good enough. I'm quite pleased with that. Right, hope you enjoyed that. You can watch some of this footage of the steady rest fingers being made. Thanks for watching.